Thank you. My name is Loren Staley. I'm the CTO of Edgecore Networks. Been with them about 5 years. Prior to that, I was 31 years at what's now called HPE. And my background is actually servers and storage, and a lot of product development experience. Acton Edgecore, well, I'll explain this in a second. So we started doing this journey into open networking about 6 or 7 years ago when we saw the trend starting to happen. We've been in developing this type of the marketplace for that period of time. There's two companies here. Acton is the parent company. They are mainly the R&D and manufacturing arm of what we do. Edgecore is a wholly owned subsidiary, go-to-market, and we represent the #1 market share in open networking hardware. This is per IHS market analysis. Just to kind of get our perspective on what's happened over the years. So in the last 15 years or so, unprecedented change in terms of data explosion. The top picture here is Vatican Square in 2005. No smartphones. And this is the same area in 2013, pervasive smartphones. And one of the results of that is what we've seen in the last 5 or 6 years, in particular with the various service or data center providers like Facebook, Amazon, Google that are providing all that data. And clearly in those data centers, there's been a huge change in terms of scaling and demand on infrastructure, compute, storage, and networking to make that happen. The pending result is what we're seeing right now, which is this huge scaling demand on the internet, wired and mobile network. And you can obviously understand the need for increasing bandwidth and decreasing cost in order for those carriers to actually stay in business and make money during the coming years. You'll notice on the left side of this chart, there's a lot of stuff related to PON and wired access. And on the right-hand side, a lot of stuff related to wireless and mobile access. And we'll come back to that in a few seconds here. Open networking evolution. Edgecore, as I said, started 5 or 6 years ago investing in this market. Obviously, our first stop was data centers, and this is represented by OCP and the work that Facebook set up for that forum. We started off with 10 gig or 10 gig racks and 40 gig spines. We're now currently working with 50 gig racks connections and 400 gigabit spines. And you can see the progression through that. We've also branched off into a couple of other areas related to open networking. On the top of this is service providers, as represented by OCP, TIP, and ONF. And then on the bottom, some of the enterprise and managed network stuff, open Wi-Fi, PoE switches that run open networking software, and some of the lower end access devices. It's interesting to note that a company like Amazon, they run huge data centers with their AWS network. Turns out they have these huge warehouses, and they like to have the same software set in both of them. So we sell a lot of products to Amazon that are PoE wired hubs for connecting up scanners and cameras and stuff.
Oh yeah. What about Facebook Voyager? Have you been participating in that project?
We have not been participating in that project. The idea is a very interesting idea. We'll talk about a product that we donated to TIP last year in a few minutes.
Yep.
As a kind of alternate to that approach.
Okay, sure.
Obviously, from the point of view of architectures, the first is the standard class. I'm sure all you guys know this one. The first attempt in the carrier space is related to the same class architecture, but modified in order to meet the needs of carrier markets. So you can see things in here in terms of OLT, some edge computing devices, and a lot of difference between using what I would call kind of a layer 2 network-centric ASICs and carrier-grade ASICs. And that's the difference between the Strata XGS and the Strata DNX lines at Broadcom.
Just got a question for you about the PON OLT platform. Is that something that IP Infusion is looking at putting software onto in the future? I've read some about the white box OLT initiatives, but I'm curious if that's in the cards.
I will deal with four projects here, four products in specific related to what IP Infusion is doing. So
gotcha. Okay, great.
We'll get to that. Talked about links. Don't need to go over that anymore. From an open networking point of view, Edgecore kind of has this focus. So we work on open hardware, and our intent is to be leadership in the open network hardware development side. So we have key relationships with all the key silicon vendors: Broadcom, Innovium, Barefoot. We have agreements with them to do early access to silicon and support their architectures. We have a software development team that's really focused on enabling the software infrastructure, and that includes both commercial software vendors like IP Infusion, also open software environments like ONF and others. And the last thing we do as a go-to-market organization is partnerships with integrators. And we're different in that regard. Some of our competitors are network switch providers, and they also have groups that do integration. We don't do that. We work with partners that are very strongly in the integration side of things and support them in their efforts to deliver product. That's really important because most of the consumers, big guys, Facebook, Amazon, talk about the carrier providers, they don't get things delivered directly. They always go through an integrator that supports their deployment strategy. Edgecore has made the most networking contributions to the open source community, both OCP and TIP or TIP. And we can come back to this if you want. You're mostly probably aware of some of this. I'm going to focus on the service provider line, so the top line of this. That is where a lot of the current work is going. We started working with some of the service providers about 3 years ago and trying to help them understand what the transition to white box means, what it is that we can bring in terms of products, and a lot of really interesting questions about where do you have redundancy in your network, how do you support your software, writing it yourself or not, how do you QA the software that you're going to use, how do you support the deployments in this environment. So this is kind of a diagram that just kind of shows what's happening in these networks, both wired and wireless. And there's some similarities to these. In the past, a lot of the carriers have had separate networks. So they have the telephone network, the broadband network, and the mobile network. They've tended to be separate. Now they're all realizing that they can't do that anymore. The next round of technology, for both cost and performance reasons, those networks have to collapse in order for them to create an infrastructure that they can monetize and be profitable on. And so on the left side, a lot of stuff related to PON as an access network for fiber. On the right-hand side, a lot of stuff related to connecting up base stations, both for 5G and 4G. Regard to your question of Voyager, this is the product we brought to market, Cassini, and trying to basically reduce the cost and create more of a standard model for doing coherent interconnect.
Yep.
It's intended that a box like this would drive a DWDM network.
Mm-hmm. So you see it as an interconnect, not as an edge?
It can be both. So the design intent was for data center interconnect.
Yes.
But there is some large part of the carrier market that could use this for their
as a low density optical switch because the Acacia transponder's got enough. Okay. That's probably worth emphasizing, that DCI capability. This is enough to provide 400 to 1.2 terabits of bandwidth between two data centers, this one box. Mm-hmm. Right? It's got optical transponders in there.
1.6 terabits.
Okay, sorry. Thank you. I'm glad you're here. You could put 2 of those boxes and you could have up to 1.6 terabits of bandwidth on a DCI between your data centers, 80 Ks on an average cable. You might be lucky and have good dark fiber.
Yeah.
So for those of you who are running 2 data centers 50 kilometers apart and you're renting bandwidth from telcos, these boxes could just upend your whole model. And you could start cheap and then just clock up the optical rates as fast as you want. None of this 10 gig, 40 gig. We're talking 100 gig, 200 gig, 400 gig.
It's a good point because I specifically, not with this box, but I specifically use that use case for DCI connectivity with DWDM to raise that with Edgecore switching to do that about a year ago.
And this is a Broadcom ASIC in there doing the Ethernet, and there's a standard transponder, effectively a merchant optical chip from Acacia that everybody seems to have agreed on as being a standardized optical. So now you can go and buy your white box operating system to run on this. Choose your favorite flavor.
Yeah, so this box tries to do a couple things. One is it combines switching and what's it called?
IP optical edge.
Yeah.
I guess.
Gosh, I can't even remember the words now.
Probably got a fancy name. Telcos would give it a weird name for
it
fun.
combines switching and transponding into a single box. So this could be a leaf in a folded cloth and just go kilometers away. It's also modularized to the point where you can use various sorts of technology for ACO, DCO. You can configure it with more standard gray ports and less colored ports if you want to oversubscribe your links. And we have a lot of partners in this one. So IP Infusion is a partner that's running their software on this. Obviously Acacia, Finisar, and you'll hear from NTT a little bit later. Again, a couple different line cards. The DCO is the one that Acacia has a module for now. Others are working on it. The ACO module uses an NTT DSP internal to the line card.
Right.
And I think there's 6 or 7 different people that make ACO pluggables for Coherent at this point.
It's going to burn a lot of power.
Second product here is the VOLT16. So this is an XGS PON device. It's based on Qumran AX and the Maple silicon from Broadcom. This one supports XGS PON. I think you could do NG PON too if you wanted to. XGS PON seems to be a good cost center. So this is our first attempt at an OLT box. We are also working on other OLT-related boxes in terms of particularly GPON. So one of the feedbacks we get that XGS PON is great for urban areas and with business customers, but it's way too expensive for what people want to do for fiber to the home or such, and places where GPON actually is fine for a particular set of customers. So we're investing heavily in this class of product.
Do you see yourself growing the market with that or taking market share away from competitors?
From what we've heard, probably a growing market.
Right.
And part of the trick is trying to get the cost point of that down to the point where some of the more emerging economies, India for instance, can adopt it as a way to connect up billions of people with fiber.
And 5G would be an opportunity for this as well.
5G, we'll come to that when we talk about cell site routers.
Okay, yeah.
And this is actually a picture of the cell site router that we're working on right now, again with IP Infusion porting their software on top of this.
Wow, so is that going to run an APC? Is that going to run an EPC inside the box, or is it not handling that function? For the LTE solution, is it running an EPC inside the cell gateway router for the node B, or is it just It's just IP packet attachment?
It's IP packets. It's after the cell tower equipment.
Gotcha. I was just curious if it was handling that function.
We have explored third-party software where you could run these stacks for the LTE functions. So that's an option.
So you're looking at like some kind of containerized option to put the EPC right next to the gateway so that you can basically create that 5G LTE aggregation?
Yep. That's one option. If you want to run it inside the box, yes, we have the container or VM to enable that.
So your EPC partner could come and drop the gateway on top of the box if they wanted to.
Right.
But that would be a CORD ONAP type discussion, not because you would provision it out of the ONAP.
Right, I was just curious because EPCs are trending towards smaller and more decentralized. And
Yes.
to like right at the tower, which is why I was curious if that was headed in that direction.
But they're looking at the open CORD is the tool that would deploy that. So if I don't miss my guess, IP Infusion would say we've got a container, you could deploy that onto our box. But the telco might choose to have an x86 server there and deploy it into a white box x86.
And then hand IP off into the gateway
and just
switch.
use this for the switching and routing functions.
Yeah. So I'm not quite sure whether this fits as part of the equipment you use in a CRAN type of, deployment, or if it sits someplace else. And the thing to note here is, the uplinks from this are 100 gig, right? So the whole world is moving to 100 gig as a fundamental interconnect. And also, as I mentioned before, this is a very highly capable cell site router for 5G. And we're also looking at doing lower cost, lower capable cell site routers because there's large parts of the world where 3G and 4G is just fine. And then the last product here is a deep buffer switch. So this is based upon the DNX architecture from Broadcom, Qumran MX. Here's the huge difference between these in terms of this can provide 8 gigabytes of packet buffer compared to 42 megabytes, I think, is on Tomahawk 3.
Wow.
So places where you have, latency concerns or traffic management concerns, the DNX architecture allows you to create huge buffers to
That's always been
a
challenge for long-haul transport for carriers is a deep buffer switch to be able to, because 100 gig in a data center is one thing, 100 gig over 2,000 miles is quite another. So this is, I guess, addressing that problem.
Addresses that problem. And also, you want to use something like this with the extra buffering and stuff where you're doing either latency concerns or you're doing traffic engineering, right? So if you're trying to throttle or do traffic engineering where you have to throttle up and down things based on quality of service and stuff.
Yeah. And when you're switching speeds, when you're stepping down from 100 gig to 50 gig or 25 gig, you need the deeper buffers.
Yeah, and so this is a validated platform for IP Infusion because IP Infusion already has fast reroute, traffic engineering, now segment routing for OSPF and ISIS. So if you had a platform like that, if you needed an MPLS backbone or multiple MPLS backbones, that would be a great platform to marry it with.
Right. So this is something data centers currently don't need, right? The data center guys, they want as fast as they can, aggregate bandwidth,
lowest latency,
and they never run their networks near the edge. The carrier guys want this capability, and they want it to be clean when they get near the edge of the performance envelope. What was I going to say?
Even in the carrier space, everything is becoming a data center these days, right? So I work for a big carrier, and we're thinking about deep buffers to use at the edge of the data center.
Yes. And we do hear that from the carrier guys as well, that we may build a standard data center, but we get to the edge and go out into the transport network or whatever. We need this as an edge connection.
Yeah, it's a gearbox.
And the other thing about this is it's both extensible in size of the packet buffer, but also in the size of TCAM. So most of these chips in the Dune architecture have the ability to add external TCAM. And we regularly include that in our designs as an option. So this is actually my last slide. So as Edgecore, we're investing across the market, data center, service provider, enterprise, CPE. We are gearing towards white box technology leadership, so we follow and work very well with First Silicon coming from different partners. I mentioned the Silicon partnerships, OCP, and we have the broadest set of software partnerships that we've developed over the years. I think we have 18 different commercial partners that we work with, including IP Infusion as a key one. We're involved in all the open source communities and supporting those efforts. Although in the open source community, the two questions always come to mind are who's going to QA the software and to what level that a provider would want or a service carrier would want to deploy it, and then who supports it in the open network business.